Good morning and welcome to the CABE webinar Wednesday. Today we are looking at the unintended consequences of retrofit with Tim Kenny, residential surveyor and SAVA trainer, MCABE. Retrofit projects can quickly go off track when the existing condition of a property is overlooked. In this webinar, we'll explore common pitfalls that arise when upgrades are carried out with addressing underlying issues first, such as damp, structural defects and outdated systems. My name is Zaina Kennedy, and I am the Training and Learning Coordinator here at CABE. I will be acting as moderator for this morning's session. CABE strives to create interactive webinars, and if you are watching live, you can use the Q&A function to submit questions, which will be addressed at the end of the session. You are also welcome to contact us at webinars@cbuilde.com. Let me introduce today's webinar presenter, Tim Kenny. Tim is a residential surveyor and has been a DEA home inspector and property manager in the past. Along with authoring 2 sections of iServe for RICS, he has also been a contributor to the RICS Building Surveying and Residential Journals. Both in teaching and in his own business, Tim is focused on how surveyors can deliver the highest possible quality of customer service and benefit to clients. Outside of his day job, Tim is also a yoga teacher and runs regular webinars for Lionheart, a charity that supports RICS members. So now I will hand over to Tim to begin the presentation. Over to you, Tim.
Perfect. Thank you very much. Let me just share my screen. I'll make sure I'm sharing the right screen. Perfect. Hopefully you can all see my share screen now. You see my presentation. So as I said, we've already had a bit of introduction to me. But I just want to introduce SAVA for those that don't know. As I said there, I'm a SAVA trainer. I work on their the diploma in residential surveying evaluation, long-winded title. But as you can see what they do there, they empower individuals and organisations to enhance and improve these buildings by equipping them with skills, knowledge and technology needed to understand and assess properties effectively. A training organisation, we give people knowledge they need to deal with their buildings properly. That's kind of what we do, whether it is through residential surveyors, housing associations, energy efficiency things. They do all sorts of bits and pieces and are getting involved. So a bit about me as well. So there, my name is Tim Kenny, for those that don't know me. And first and foremost, I am a working surveyor. It is how I earn 95% of my living. But on top of that, I do some training for SAVA. I'm a lecturer for the University of the Built Environment, what used to be University of College of State Management. They've shortened it now. We're just University of the Built Environment, which makes much more sense. I'm also currently a member of the expert working group working on the RICS home survey standards. If you don't know what they are the set of standards that RICS members are obliged to use when providing a home survey. We have currently, or very recently, issued our draft revision, which is out for consultation. If you are an RICS member, please do track that consultation down and share your views. Even if you're not an RICS member, you are welcome to share your views. If you are a surveyor working in home surveys, then ultimately you are impacted by that document, whether you're an RICS member or not. It is the kind of the benchmark document for the courts will use. So if you want to share your views, get on the consultation and share your views. It is open to everyone. On top of that, I'm also part of the newly formed working group working on giving guidance on how we as surveyors inspect properties with energy efficiency measures. I know we've used the term retrofit, it's in the title of this presentation, but we're now trying to move to this slightly more nuanced term of energy efficiency measures. Retrofit is a very, very broad term, and it's got other connotations and bits and pieces around it. So we're trying to kind of release that a little bit and stick more with energy efficiency. And hopefully it's obviously quite a new working group. We're still working through some bits and pieces with it. But eventually we will have some guidance again, guidance for RICS members, but that guidance is available to everybody and should be of benefit to everybody who has to look at buildings that have had energy efficiency measures. What we can say about them, what we can understand from what's there and what's going on with it. Right, so I was just given a title for this webinar and said, produce a webinar. I know you've had a nice introduction telling you what I'm going to talk about. I'm probably not going to talk about that as it turns out, because, you know, as I was kind of putting this webinar together, you know, it could very well easily have been a crash bang wallop what a video for retrofit. We can put up some nice dirty pictures of retrofit gone wrong. We can all laugh at the people that have had to put external wall insulation around the signs, around the gas meters, and we can talk about what goes wrong with that. And there's value in that, but to me, it's kind of been done. And I wanted to kind of look at something slightly different with this. And I went more with the idea of this unintended consequence. Some of the things that can happen despite even the best meaning intentions of those involved. Even actually some situations where technically people are not making errors, but actually there are going to be unintended consequences. And we need to understand that. We need to allow for that. We need to find ways to deal with that when we interact with our buildings and also the people that live in those buildings, which are, much as we maybe sometimes we'd love they didn't get involved. And fundamentally, our buildings are generally speaking for people. So we have to allow for how they use them, what they do with them, and we have to deal with them, much as we might not like to sometimes. But before I do all of that, so no, broadly speaking, I'm in favour of retrofitting our buildings. I think this is what we should be doing. We can have some arguments and some conversations about, well, actually, if we improve energy generation, then retrofit doesn't matter, and all of these sorts of things. And of course, we recognise that it can go wrong. We also recognise that it can go right. And whenever I talk about this subject, I do always highlight this and highlight the work of historic England more generally, particularly if you are dealing with traditional buildings. And to be honest with you, a lot of what they're doing, although they're focused on traditional buildings, obviously they deal with the listed stuff. A lot of this stuff actually is beneficial for more modern buildings as well. And this broader understanding is really helpful. So I always flag up this study, came out in 2023. So energy efficiency and holistic buildings, assessing the thermal and high growth and thermal performance of 2 refurbished dwellings. Really interesting, useful study, and presented really well, really understandable, really accessible. Even I can understand it. We take the first bit, we can read through what they do. And they strip back these 2 buildings that you can see on the right to they're kind of fundamentally their bare bones. And then they improved them as much as they could. Kind of to see what would happen, right? To see what obviously the thermal benefits are, and we can see that they got some reasonable thermal benefits. Quite well, actually, one of them they managed to make it worse. I don't know, but they did. That rear above the fireplace, we don't know what happened with that, but they proved that yes, we can improve the building, and that's really important. But they also looked at the other side of it. Is it going to cause a problem? Is it going to make something go wrong? Is it going to be an unintended consequence? And they found that there kind of was, insofar as there was an increase in the relative humidity within the structure of the building. So what they did is they left kind of data loggers within the wall, collecting information about moisture levels within the walls. And they collected that information. They looked at it. One of these buildings they looked at for 7 years. So they got some really, really good long-term data. And what they found is that, yep, it was getting damp in the winter. But in the summer, it was drying out. And it was drying out to a point where it was okay. As we all know, moisture is a problem, but it's a problem if it hangs around. If it gets wet and dries out in a reasonable timescale, that's no issue, really. It's just passing through and moving in and moving out. It's kind of how these buildings were intended to be. Also, when we talk about vapor permeability, we talk about breathability. That's how they're supposed to function. And to their mind, that's what it was doing. Okay. Now, of course, it was hanging around a bit longer than it might do otherwise. And what they found was the material they used was retaining water against the wall, but still was drying out sufficiently. Okay. Obviously, they said, you can't be certain. It's just one building, just one period of time. Really, ideally should know better. But from what they did, they said there wasn't an issue. And it's all really good. And I say I like the study. It's well worth a read if you haven't read it already. Kind of couple of one or two caveats to that is, of course, the data they collected was limited. They focused on walls. They didn't focus on the floor as well. So they insulated the walls, but they also insulated the floor. And as someone who is fascinated by suspended timber floors, I think that was a missed opportunity to understand how that floor was affected and the kind of the consequences of that insulation under the floor. Other thing to note is, of course, historic England, they did everything right. They used the right materials, they used the right contractors, they oversaw the job properly, and they made sure everything would have been finished the way it should have been. Because we know we've all seen the pictures of the insulation around the sign or around the gas meter. We've seen the badly fitted stuff. We've seen the pictures of the condensation. So we know that in the real world, outside of a study funded by people who are specialists in this area, work is not carried out to the best possible standard. People who are giving it a go. It's a kind of a slightly almost a boom industry at the moment. Funding through government and everything else that's coming through that process means that we are seeing poor works carried out. So just because this one says actually it's okay to do, doesn't mean other properties done in other ways, in other situations and other locations will perform exactly as well. With that in mind, I want to talk about cavity wall insulation, and particularly cavity wall insulation in terms of location. And we've been, retrofitting cavity wall insulation, retrofitting insulation into our cavity walls quite a long time now. It's a relatively common retrofit. It's probably the kind of it's the first really of this, other than maybe upgrading windows. It's kind of the first of the major retrofit projects that took off and was carried out. So it's fairly well understood stuff, isn't it? We know we have our exposure zones, and we can refer to where our property is in that on the little map. And we can identify the exposure zone. That tells us, the extent of water we're expected to get in a heavy downpour. How many liters per meter squared per spell of wind-driven rain. And depending on what area we're in, we can then refer to that approved document, and we can decide what level of protection the property needs from wind-driven rain. Because obviously we know if we're going to insulate a cavity, we are bridging the internal and the external wall, which means we've got a route for penetrating damp. One of the biggest drivers of penetrating damp is always going to be wind-driven rain. Obviously we've got gutters and bits and pieces, but wind-driven rain is always going to be the biggest driver of it. So we know that if we're in an area of severe wind-driven rain, we're going to have to protect the property. We know that an external masonry wall is never going to be 100% watertight. That's why we require weep vents to be put in modern cavity wall buildings. Even though I was going to say, even though they're well built, we know quite a few modern cavity wall buildings are not well built. We also know a lot of weep holes are just pretending to be weep holes, but that's a whole different issue. Building regulations assume reasonable standard. So we require those weep holes to be put in because we expect some water to get in, and therefore we need to give space for it to drain out. And that's all fine, and we can all understand that, and that's all kind of the easy stuff. We can deal with that, can't we? We can work out what fill material is suitable. We can work out what we need to do on the outside to protect it because we've got this hard data. This is really good, government approved, definitive information that we can rely on when deciding on what we can specify for a building, or if you're like me, come in and look at it afterwards. I can look, okay, yeah, there's insulation in there. I can pick out the exposure zone and I go, you know what, yep, it's insulated. There's nothing on the outside, but we're in a moderate zone or a sheltered zone, so it's probably going to be okay. Right? We can put that together and go, you know what, yep, I'm happy with that. That's fine. Because it's not. It's the honest answer, and it's not because of this. So back in 2024, Department of Energy, Security and Net Zero released this report. And what they said is that under projections for how the climate is going to change, we are going to see potentially up to 25% more wind-driven rain in some regions. Okay, map on the right there. They are locations of weather stations. Wait 2 seconds. 2 seconds. Yeah, so please do. I was going to say, someone's put a question in. I will try and get around to those at the end. If I don't, you can bug me or whatever. We run out of time. It's always possible. I talk too much anyway. But we will try and get to those when we get towards the end. So these are weather stations where they've measured, obviously, the wind-driven rain. And you can see that in some locations, the longer the line, the more wind-driven rain is coming from that direction, or more wind is coming from that direction, and therefore carrying more rain with it. So, some of these fairly even, some of these you've got a big variance. We can see fundamentally, we should know that our wind-driven rain, our prevailing winds come in from the kind of the the southwest, okay? Coming in from that direction. So we know that the south and southeast corners of our buildings aren't going to be closed. That map proves it. But I said, they're expecting up to an increase of 25% based on predictions of calculations around global annual surface temperature increases. That's how we measure the kind of the underlying metric for climate change, is this global surface temperature change. And they reckon between 2 and 4 degrees, we can get 25% more wind-driven rain. And it's important to know that. We can have conversations about predictions and how they make the predictions and where these numbers come from and what have you. I'm not a climate scientist. I don't understand climate modeling, and I shouldn't. That's not my job. There are obviously people that do that. I accept they know what they're talking about, and this is the information that they've presented. So I'm not going to sit here and dispute their information. That's not within my competency. One thing I will say is if we get 4% global surface temperature change, I don't think we're going to be caring about the damp in our buildings, because we're going to have much, much bigger problems as a species, as a society, as a planet. But these are the predictions that are out there. But even at 2%, we're going to get some issues. And we can see here, so approved document was released in 2004, right? This is the global average surface temperature change since 1880. So this is just factual information collected over a previous period. We can see that there is an increase in that temperature, and it is going up, and that increase is getting quicker, right? So we find 2004, that's around here-ish, okay? So since 2004, we're looking at 0.6, we're now at 1. So we've gone up by almost half a degree in the time that this document has been out, right? Well, actually 2% has 25%. What we can say is we are already going to get more wind-driven rain. We're going to get more volatile weather than we were expecting to get in 2004 and the members of 2010 and 2013. It's out of date. Our exposure zone, I can go back to that and go back on this presentation. Our exposure zone map is out of date. Simple as that. Technically, it was out of date the moment it was released, because it's based on historic information and we know the information is changing. But it's going to get more wrong the more time passes. As our temperature changes, as our climate changes, as the rate of change increases, this map is going to get more and more wrong. And yet we're still building to it. We're still installing installation based on that old map. Would I feel comfortable relying on it? Probably not. If I'm approaching a property that I know is in a moderate area, you know what? I'm going to be telling my client, hang on, it's got insulation. There's a higher risk of problems, and that risk of problem is going to increase over the short to long term. We know if your plant is there for 25 years, it's reasonable to own a property for 25 years. Over that 25-year period, they're almost certainly going to get a problem if it's in certain locations. Yes, if you're in a sheltered spot, that's fine, and we could consider the individual property and its individual circumstances to make sure what we're talking about to our client is correct. But this is something certainly we need to take account of that. So for me, an unintended consequence of retrofit is actually you can do everything right today, but today is not the same as tomorrow, and it's not the same as next year, and it's not the same as 5 years' time. What our buildings need, how they're going to react, the conditions they are going to exist in will be different. So we need to find some way to either plan for that when we're organising these works, or if we're advising clients where the works have already been done, to understand that they could be impacted by that and take account of that in the advice that we give to our clients. As I say, we're only allowing for the current stuff. We're not allowing for the future. And that's where we, as then the boots on the ground, the surveyors and the engineers and whatever your job role is, if you're on the ground looking at buildings, you're going to know your little micro area much better than anybody who's written this document that is intended to deal with all different types of housing or all different types of building, the entire built environment within a country. I know my patch. I'm based down here. I don't know if you can see my cursor. I'm based down here near kind of, you can almost see Selsey Bill on that little map there. I'm based in Chichester in West Sussex. So I understand where the risks are and the properties that I see and where the level of risk in relation to those properties, and therefore I can tailor my advice to meet that level of risk as they're starting to move through. If we've got any Sava students in the group, the ex-Sava students, any current Sava students, you may remember this building. While we're still talking about cavity wall insulation, and I'll have on this. Just to give a bit of background for those that aren't Sava students, used to run a session for Sava. This is a building that was used for kind of the practical days. We had students in and out assessing this building, looking at it, drawing up reports on it and what have you, doing all that. And one of the sessions we ran for them was talking about, okay, well, look, this is the building. How are we going to go about retrofitting it? We're talking about what was an end terrace, now what was a mid terrace, now an end terrace, standard Victorian property, right? A lot of solid walls and bits and pieces. But what's also happened is the construction of this gable wall, this cavity gable wall. So originally was a mid terrace. Part of the terrace was removed to allow for the construction of a new estate. Obviously, you can't just leave the bare party wall, so they had to do something. Of course, there's lots of options for that. You could knock it down and rebuild a whole new cavity wall on the outside, or you could go what they did in this case, just tack a cavity on the outside, tack another wall on the outside, and you can see we've got a couple of wall ties just visible in this section. That was about all the wall ties they used. Some of these wall ties were into timber, some of them into block work, all sorts of nonsense going on with that, right? But of course, you don't know any of that from the outside. You can't tell. And we ran this session for a couple of years with this building. And most students immediately went to, okay, well, insulate the cavity. We tell them, okay, how are you going to improve the thermal efficiency of this building? We'll just insulate that cavity. So it's a big old cavity wall. We know insulating it improves it and everything else. Let's just do that. Of course, what they didn't know, and from looking at it from the outside, is that, yeah, this was a real unknown quantity. And certainly that would have given me pause for thought, the fact that there's a lot of unknowns to it. But those unknowns kind of proved correct. We've got a massive lack of wall ties within this structure, because obviously they're probably a bit tricky for them to fit. So we just won't bother doing too many, because we're not really making money on this house. We're just having to do it because we're made to do it. We saw here that it was water getting in at certain points, rotting all of the timber. This here, literally, they were just removing bricks by hand. A lot of this had all just turned back to sand, and they were just literally lifting these bricks off because it was just poorly constructed in the first place, or it had deteriorated over time. Now, of course, if we'd just gone ahead and insulated that cavity before carrying out a full and thorough inspection and understanding what's going on and looking at it, then you'd have an additional problem, wouldn't you? Or at the very least, you'd have wasted your money on the insulation, because that's all going to have to be redone. It's certainly going to make a lot of this work more complicated. And I will say, and this building, as I said, literally hundreds of students have been through here, and they were accompanied by some really, really good surveyors. Sava use, sounds like I'm boasting, but other than me, they use some really, really good trainers, some very experienced, very knowledgeable, really, really good trainers, and really good surveyors. And these surveyors have been there as well. Actually, they hadn't really identified this problem because you couldn't. There was nothing to see. It wasn't until one of them went, you know what, I think some of those cracks are getting a bit bigger. There was a bathroom below this, and it's starting to look a little bit like something's moving there. You're probably going to want to get this investigated further. It wasn't until they did that they started to realize the significance of some of these issues. But before then, for 5 years before then, something like that, nobody could really see that there was a problem. So just on that surface level inspection, looked fine. And the easy assumption is we'll fill that cavity. But of course, we'd have some massive unintended consequences. Okay, so another form of standard insulation, so external wall insulation. And I didn't really want to bring up pictures of bodge jobs, and not necessarily saying this is a bodge job in a nice possible way. But what I will say is that I wasn't here to look at the insulated property. I was actually here to look at the kind of the peachy one on the right. My client brought me in because they were concerned about movement to the party wall. There's some fairly significant cracks that were opening up. Turns out people next door had just decided to change the direction of the floor joists and hadn't taken account of the things that they should have taken account of. So we had some movement going on. Now, of course, that wasn't the only issue I saw with some of the stuff they were doing. There was some real bodge up going with the rainwater goods at the back as well. Of course, if you're gonna bodge one thing, are you really gonna make the effort with every other part of that installation? Probably not. Can we trust the quality of this based on the quality of everything else we've seen? Probably not. Those that are residential surveyors probably are well aware of the case of Hart and Large. Lots going on in that case, some big figures in terms of the claim and the damages and how damages were awarded. But one of the most significant things for me, that one of the big take homes I think for surveyors that was missed, is that, you know what, if we're seeing poor work in one form, and we know other work's been carried out at the same time under the same instruction on the same supervision, well then we should assume the stuff that we can't see may have a higher chance of problems. Okay. And the way I take that, you know what, if we're turning up and we're looking at a property where energy efficiency measures have been carried out, and we can see that whole property perhaps was renovated as part of those works, which is common. You know, people like to do this stuff while they're renovating the whole property, and we'll look at something specifically on that towards the end. But if we're looking at it, and if on the face of it, it doesn't look right, if we see something that niggles us as a surveyor, even if we can't say, you know what, there's a definite fault there, you know, and it might just be that there's a real kind of bodge up on the plaster, we should be saying to ourselves, you know what, that gives me cause for concern. There may well be things happening within that I cannot see, and therefore I need to flag up to my client that there may be further investigations they have to carry out to reassure themselves that the work was carried out well. So in terms of Hart and Large, that would be a request for a PCC. And effectively it says, don't buy it if you don't get given a PCC in those circumstances. But again, it depends on the specific circumstances. They're already owning the property. It might be inquiries through the contractor. It might be opening up works, whatever the situation is. They should be investigating further. And as I say, Hart and Large was about the total renovation of a property, but I think that applies equally well to where we are seeing any form of energy efficiency measure carried out at the property. On top of that, there is another, I think, unintended consequence we need to be very mindful of. So, of course, insulation works well when we are making all of the element the same thermal efficiency. So if we can make all of a wall the same thermal efficiency, that's good. We don't get cold spots. Of course, we're going to get cold spots around the top and the bottom and around windows and all the other openings. And if we've got any way we've bridged that insulation incorrectly to the wall, we've got the potential for cold spots. So that always, you know, a risk within the subject property itself. But what about next door? You know, this wall is the same wall as that wall. It's not any different. It's the same element from my point of view as somebody looking at it. Because of the work done, even the party wall that should have been connecting, separating them two, was starting to move away. So in more ways than one, they were the same wall. And yet the one on the left is going to perform very differently to the one on the right. And the biggest point of difference is going to be along the party wall. So immediately we've got a risk, not to our property, not to the subject property, but to the neighbouring property, because they haven't been insulated. So we've got that chance of a cold spot fundamentally running along the party wall. Are we going to get issues around, you know, damage to a neighbour's property? That we need to understand in relation to this. Should that make sense to take it across? You know, there are detailing issues that need to really be considered in those circumstances. Now, it's fine if you're a housing association, you own the whole terrace and you can do the lot, great. One property out of a terrace, leaving the other. To me, that suggests there could be problems building themselves up in the future. Okay. Air source heat pumps. They're a controversial subject. Let's put it like that. They're not everyone's kind of not everyone's cup of tea, and that's fair. You know, we see plenty of This was just a really quick sample of headlines that I pulled up. There's key papers that talk about them a lot. I won't make judgments on that, but they do, and they have their opinions. Personally, I'm a bit more guided by people like Historic England. If you don't know, Historic England work out of a converted mill building somewhere up north somewhere. So I live on the south coast. Everything's up north for me, but somewhere proper up north. Converted mill building, as Historic England are, they're not ones for massively changing. They like to keep the heritage of buildings, and that's what they're for. And God bless them for that. But they did decide actually they want to heat their building from a heat pump. If you look at a lot of the narrative, a lot of the conversations, a lot of the kind of the stories that are coming out, trying to heat a converted mill building with solid walls and timber windows and what have you, using a heat pump, recipe for disaster, isn't it? If we think about some of the things that we're being told through the press, but actually they're quite happy with it. Used correctly, using the right pump in the right way, really happy with it. They found that, you know what, they didn't even have to change much of the radiator. They already had enough extra capacity in the system, because obviously most heating systems are not correctly designed. They're not completely thought out by an engineer. They're just, okay, well, let's put roughly that size radiator under that window and another one in there and another one in there. No one's really thinking about these things in the right way, which everyone's just taking their best guesses normally. I mean, yes, some things are done right, but realistically. And obviously that increases as you go back in time. And they found actually, you know what, heat emitters were fine based on what they were seeing, what they needed to do, and if they were thinking about how the system was used and timings and all of those sorts of things, they were able to make it work well and efficiently and make savings and what have you. So I take a lot of it with a big old pinch of salt. But of course, if what is said is true, then of course, if we see a heat pump at a property, we are right to flag it up and say, you know what, there's a big risk. Or if we're being asked to consider the installation of a heat pump at a property, we can say, actually, you know what, there's some big risk with that. Consider and pause on or make different choices. But for me, the risk is not that heat pumps don't work. The risk is not that heat pumps are not efficient. And to give a little bit more background, hopefully you guys are probably all kind of well aware and good, competent surveyors and building engineers and what have you. But a heat pump obviously runs on electricity, right? So it uses a pump, as the name goes, to pump refrigerant around, and the kind of expansion and contraction of that is how it kind of releases heat. These things can be 300-400% efficient. So for every unit of electricity you put in, you get out 3 units of heat. Okay, it measured into the kilowatt hours. That's great. It sounds really good. You're almost like getting free heat out of that. And that's great. And when you compare that to a gas boiler, a modern condensing gas boiler, just over 90% efficiency. So we're getting this 3 times or more than 3 times benefit from our air source heat pump. Problem is, electricity is 3 to 4 times more expensive than gas. You know, although we are obviously more and more renewables are coming online, and that does change the mix a bit. Fundamentally, gas is used to create electricity. So, of course, if you're competing with the electricity generation market for gas, you're competing on price and everything else. So, gas is a kind of a cheaper option. Then obviously you have to process the gas and make electricity and generate it, so there's additional cost. Which of course means that you're already skating on a fine line with your air source heat pump anyway to get a benefit in terms of cost. You're always going to make a benefit in terms of carbon release, but cost is a metric that most people might think about first. And you lose that very quickly if you get the design of the system wrong. If you undersize the pump, heat emitters, or if you operate that system inefficiently, you will lose all of that benefit. Okay. Now, of course, operation of the system, unless you are responsible for, you know, those protocols within an organization. For me as a surveyor looking at properties, I'm just I can't tell them how to use it. I can point them in the direction of the right advice, but if they choose to use it wrong, that's down to them. So I can't worry about that side of it. but I can worry a little bit about sizing of heat pumps. Okay. Now, I'm not going to suggest we need to think about, don't need to be designers and engineers in relation to understanding all of this. And I know there are people with heat pumps that are properly geeky about it and can probably tell you the ins and outs of it. I don't have a heat pump, so I haven't gone that far. I've just tried to take a good understanding for me as a working surveyor. But I'll give you this example. I saw at a property. So this is a heat pump that was installed for this building. So this is a converted barn. Converted, I think 10 years ago now, maybe a little bit later. Fortunately, they had filled the loft with spray foam, which is always a concern. And one of those, we could have talked about spray foam as a retrofit measure with unintended consequences, but I think that one's been. If you don't know about spray foam by now, then probably you need to go away and do some really hard thinking. So I'm sure we're all aware of the issues on that one. But obviously it was a concern, and as common with all these installations, no paperwork, even though it was done as part of the whole renovation work and everything else, no real paperwork on it. But otherwise, just solid walls, no external insulation. Got some timber double glazed windows, but obviously very narrow, not particularly high efficiency. Underfloor heating, which is beneficial to do with the way air source heat pumps work, but nothing special. It wasn't designed as a high efficiency building. It was just a building, so a decent enough barn conversion. And they fitted this air to water heat pump. So there are two types: air to water and air to air. I'm focusing on air to water with this one. Air to air is something we probably may see more of in the future because of its ability to cool and everything else and what have you. But air to water is the standard one that we see, or is kind of being pushed forward in relation to a lot of these buildings. So we kind of have to understand, this is the label on it. We have to understand what some of that means. So in this case, we have a rated heating capacity of 11.2 kilowatts. So this is the amount of heat it can produce at optimal operating conditions. Optimal operating conditions, nothing ever works at optimal operating conditions. This is kind of like your range on your electric car or your MPG, and predicted on a diesel or internal combustion engine car. The manufacturer will tell you it's got a range of 350 miles, but in reality, that range will be very much dependent on how you use it and the external conditions. And it's very much, same with an air source heat pump. How well it's used and how warm it is inside and how warm it is outside will all impact that amount of heat that it can produce. And then it has a coefficient of performance, so 3.34 in this case, which means that for every unit in, we get the 3.34 units out. So this is 334% efficient at optimal conditions. This property is 50 meters square, 8 rooms, underfloor heating, limited insulation applied to solid flint rubber walls. Right. So we know that it's not the most well insulated, but this one is starting to this is doing okay as far as we can tell. No signs of condensation that might imply unheated, not heated appropriately. No particular complaints from the sellers saying actually, yeah, you know what, we're getting a bit cold. Not that they would tell me as the surveyor that, but to the best of our working knowledge, this system is appropriate for this property. Okay, so we need to kind of understand some of that. Say, you know what, fine. We also need to know the higher the demand, the higher heating required. So if you have a lot of heat emitters, so radiators or a big area of underfloor heating, then of course you're going to need a higher rating capacity, right? Higher heating capacity. So 11.2 is okay. It appears to be okay for this one. If I was looking at, it was rated at 7.3 and I've got quite a big house, I might be concerned. Now, of course, I'm not going to say, you know what, yeah, that's definitely a bad installation. There's definitely going to be some problems with that. But I could say it's something that needs to be considered more deeply, And it's exactly the same for gas boilers. If you've got a massive house and a puny little gas boiler, you're going to have the same problems. It's nothing special about that. You put the wrong system in the wrong property and demand too much of it, you're going to be disappointed in it. So we need to be mindful of that. Also need to be mindful of the coefficient of performance. It's affected by the outside temperature. So the kind of, in a sense, the heat pump is drawing heat from outside and pushing it into the building through basically kind of this expansion and contraction of the refrigerant. The colder it is outside, the less heat it's generating. And of course, the higher the demand, that's going to impact its rating, and that will drop it. It's also affected by how the system is used. If you want your house warmer inside, then you're going to have to be pulling more heat from that heat pump, which means it's going to have to work harder. And of course, different people have different desires for room temperatures. Me, anything over 19 degrees, I think is too warm in a house. I won't have a house over 19 degrees. Other people, 24, 25 is their desired temperature. So there's a personal input into that. As we said, unfortunately, we as built environment professionals, we can't really deal with the people. We can tell them, we can give them information. If they want to ignore that information, we all know it happens, and we have to just live with that. But certainly we can start to think about the fact that actually there is an element of training and understanding that needs to go along with any energy efficiency measure. If we do not train people to understand what they're getting, and of course they're going to be unhappy with it, they're going to use it incorrectly, and we'll look at really a specific example on that when we get towards the end. Overheating. Overheating is a consequence of poor retrofit. Okay. If you are looking at a property, these are various things that can increase your risk of overheating within a property. Things like urban heat environment. We've got a picture of the urban heat environments in Manchester there. Apparently it gets sunny in Manchester. Who knew? Well, we can see here, obviously little thermal insulation, that's a risk. But of course, if we're highly insulated and relatively airtight, then we're trapping all that heat in. There is nowhere for that heat to go. Because of course, insulation keeps heat out, keeps heat in, great in the winter, not so great in the summer. And we have to accept that heat is a killer. It is, I would say, obviously, I know we're dealing with everything in relation to Arab's law, condensation, mold, and all of the things that are going through that, and claims and disrepair claims in relation to that. I would not be surprised if heat was not the next big claim area. And we know these claim companies, they're looking for the next thing. There is already plenty of evidence around levels of death and injury and illness that are occurring in relation to overheating in buildings. It's not so much the overheating during the day, it's overheating at night, where that affects sleep, stress on the body. People then are suffering the consequences of that. So if we're not thinking about that in terms of our retrofitting, and not thinking about ventilation, not just in terms of how we remove moist air, but how we allow that building to stay cool in the summer. And we already looked at, why we were going to be getting hotter summers. We are going to get, last this summer was hot, and that is not going to be an exception. That will be the normal moving forward. So we will still see people with room temperature of 40 degrees in poorly either unretrofitted or over retrofitted properties. They will be trying to sleep in rooms with 40 degrees temperature, particularly in blocks of flats, and when they've got any of these other conditions, any other of these situations, they're not going to open their windows because of the noise. So actually thinking, okay, well, yeah, I've insulated it. You can just open your windows to help it cool down. They're not going to. Human behavior is going to play a massive role in that process. You need to think about that. Does there need to be additional mechanical ventilation because the individual is not going to operate the passive ventilation in the right way, even if it is going to cause some problems? We can accept all this. We can understand. We can see the properties in a heat island. There is a suitable mapping for that, and we can understand. We can see whether it's next to a road. We can see whether it is facing south and west, where the sun comes in and overheats it. So we've got, approved document O that gives us really good guidance on that as well. We can bring all of that into the thinking process and allow for it when we make our decisions and make our specifications, or if we're a surveyor looking at it after work, we can look at some of these things and make better assessments in relation to risk on those grounds. Okay. Last one for me, I kept mentioning this as we're kind of going along. And say that is the human element. We kind of covered this a little bit. So this is a study from the University of Cambridge back in 2023. You can see here they're talking about energy efficiency measures. And what they did, obviously, they looked at people having done work to buildings, so retrofitting buildings, and found actually, you know what? They get a bit of a saving after 4 years. After 2 years, if they put in loft insulation, benefits. They stop getting a saving. They stop getting any benefit from that in terms of gas consumption within their properties. Which sounds a bit strange, doesn't it? Because if you're going to upgrade the fabric of a building, that's a fairly fixed item. If I attach insulation to that building, that is staying there. Unless you remove it, surely you're going to keep getting the benefit. We know that if we insulate it, we're reducing the demand, the heat loss through the walls. And we looked at that study by Historic England. Reducing heat loss, so we must continue getting the benefit. But of course, they didn't. The reason why is because actually people weren't doing the work, weren't kind of operating their buildings correctly. They found actually people were just overheating them and having to open windows to let what theorized people were overheating them and then having to open windows to let out the heat in the winter because they were overheating because they got used to a certain idea of heating. This idea of kind of, okay, we turn the heating on, we make demand on the boiler, we get the property warm. Well, hang on, it's got too warm. Let's open the windows and let the air out. Not thinking about that slow, steady build up and keeping it a consistent temperature and these kind of this patterns that we use as human beings living in our buildings. A lack of understanding, a lack of knowledge about the systems and the integration of the system into the building that we're living in. They also found that we do these works, but actually, what do we do when we normally retrofit? We're normally extending as well. And of course, if you extend, you've got more space, you've got more demand, particularly for gas in terms of heating, because there's more volume of air to heat. No matter how well insulated that extra bit you've added on is, it's still going to demand heat, and therefore there's an increased cost. So we have to kind of think about all of these things. We have to kind of understand that there are people living in our buildings. People are stupid. I mean that really harsh. It sounds really harsh to say people are stupid. I don't mean like that. But we know people en masse do daft things. We all do. We're all human beings. We all do daft things, and we don't do things that to some of us might be completely sensible and logical. Sometimes because we just don't have the information. So one of the biggest unintended consequences of our retrofit works or our installation of energy efficiency measures, is they don't do anything. They don't save anything. They don't save people money. They don't save the planet because the people aren't using them correctly. So we need to recognize that there is a massive training piece that needs to go along with any of this. So if you are somebody who is designing this stuff and installing it and overseeing that and supervising that work, then you need to recognize that there is an aftercare element to that to get the best out of it. Otherwise, you're wasting your time. You're almost wasting resources doing it if you're not going to get a benefit. So we need to make sure people are trained appropriately to deal with their new building. How do they adapt their behavior to make sure they're getting the best out of the work that you've done for them? Or if you are a surveyor looking at a building where energy efficiency measures have been added in, then you need to make sure that you're giving some form of tailored advice around that, particularly when it comes to heat pumps, making sure even if you don't give them advice directly, you signpost them to places where they can get better advice and understanding, or at least flagging up to them they need to do that. Or think about how you can give them just sensible practical advice to reduce consumption in terms of usage, not just in terms of relying on the fabric of the building to save all of that for them. Okay, so that brings me to kind of this part of it. And we've got 3 questions, and if you just bear with me 2 moments, let me stop the share and see if we can get to these questions for you. Okay, so awesome. Some nice long questions. Let's see if we can get who came in first. I recently experienced where contractors installing internal wall insulation under the Eco4 scheme had drilled several holes right through 4.5-inch brick wall, so the neighbour's adjoining bedroom and stairwell, narrowly missing live electrical cables. The reasons they were fitting insulation to the party wall was it's deemed an attic room, so assumed there would be unheated space to the other side, when in fact the house was originally built with second-storey rooms partly through the wall. No party wall impact notice was served. This is a common occurrence. What is the remedy given acoustic, fire safety and general safety implications? Okay. Yeah, there you go. I mean, this is understanding that our buildings don't exist in isolation. You know, our building is sat next to another building. We need to know what's on the other side of that wall. We need to be going through that process. As I say, yeah, they've clearly ignored the need for party wall work and party wall notice and all these other things that should go along with that. Uh, yeah, I mean, clearly it is perhaps not sensible to insulate a party wall in most cases, and we need to think about that one through. Instead of heat pumps, why is there no drive for microwave boiler technology, which can use the existing pipe and radiator infrastructure? I remember O-level physics, you can't be more than 100% efficient. Some definition of detail is wrong. When we talk about, I refer to it being more than 100% efficient. It's a bit of a kind of a not quite true. It's saying that, you know, for the energy put in terms of the heat generation, because of the way the systems work, that's what you're getting out. And it's a bit of a misnomer. And we can talk about seasonal coefficients and the variation in that coefficient and all of this other stuff. As for microwave boiler technology, as I say, there are lots of different options when people talk about infrared heating and this kind of heating the person, not the space, and all of these different technologies that come in. Right now, we've got air source heat pumps. Air source heat pumps are an old technology. They've been around since the 30s. They're nothing new. They are being well used in lots of other countries. So they're a system we know does work. I think that's to my mind and why we're focusing on that's where there's the most evidence of success with them. And they are being used fundamentally like in Scandinavian countries where they have much colder weather than we do, and they are making them work in efficient ways. Now, of course, we've got a slightly different situation in that we have so much old building stock in our country, and we need to think about how those are used. And it probably is going to be the case that we're going to have to allow for much bigger heat pumps and more capacity systems in our buildings than you might do in other countries, and we may have a bigger demand for it and all of this stuff going on. But as I say, I think that's, you know, to my mind, they're sticking with the kind of the most well understood. And we've already seen that with pretty much every area of retrofit where people are doing stuff that's new, novel, not well understood. We don't know what the unintended consequences are. And we don't often know what consequences are until something's been around for several years. So to my mind, I'd rather stick with the stuff that's been around for almost 100 years than start bringing in things that they may be better. And I'm not saying they're not. And I'm never going to claim to be a specialist on these types of installation works. And there'll always be something that will come along that will be better. But it's almost like a safety first approach. Let's stick with the understood, the kind of the things that we can define. Respray foam insulation. I do not think this has yet been properly addressed by the surveying profession. I attended a CABE seminar at King's Lynn last decade where the speaker was advocating open cell foam in mainly roof spaces used in Canada. Yeah, used in Canada. It's used quite widely in cold countries. So I get some of this. It's an interesting conversation. There was a really useful study carried out by the government last year before, can't remember exactly which one. And they looked at a large number of properties with spray foam insulation and tried to identify which properties were at risk. And this is the thing, is that spray foam is not a bad product. There is no bad product in this sense. You know, bricks are a great product, but if we tried to use bricks to insulate the loft, they'd suddenly be a bad product, wouldn't they? So it's not about the product itself being bad. It's just about understanding the applications of it. Now, I can make a case for the installation of a closed cell spray foam on a decrepit roof as being a good idea, because you know what? It's going to keep that roof going for a period of time. If you do not have the money to replace the roof and you know the timbers are already knackered, you know the covering's already knackered, well, spending a little bit of money spraying the spray foam up there, that might give you 5-10 years before you're going to have to strip all of that, which means you've got time to save the money to do the work properly. It's not an approach I personally would want to recommend to anybody, but I can make a case for that. So that's not saying that product is bad. It's just used wrongly. So to my mind, the biggest issue with spray foam is not, strictly speaking, the use of spray foam. It's the lack of paperwork around it. It's the lack of inspection before and afterwards. It's the lack of information. I'll give you a case of one that I saw that kind of, I think, really highlights some of the challenges. So I was inspecting a property in Winchester, built about 7-8 years ago, something like that. When I was looking at it, they'd included spray foam in the roof. They'd insulated the roof with spray foam. And of course, that was part of the original construction of the building, therefore covered under the new build warranty that was in place. Problem is, first purchaser buying the property, valuer comes in, he'd heard about spray foam, said, oh, spray foam can be a problem, get a structural engineer's report. Structural engineer went out, looked at it, says, can't see any problems, but you really need to cut back the spray foam from the face of the rafters. So duly cut spray foams, cut back from the face of the rafters. So there I am, 7 years later, I turn up to inspect. If the spray foam's been cut back, what have you done? You've made an alteration to that building. So any defect that arises in relation to that spray foam in that roof, you know what, warranty company's just going to say, not my problem, you changed it. So already we've got a warranty that's no longer valid for that property. But, you know, I went through and asked some of the questions and tried to find out what was going on. And I was given a nice pack of paperwork about that product. It was just the manufacturer's brochure, effectively, for the spray foam. Didn't really tell me anything about that roof itself, didn't tell me about the condensation risks in that roof, didn't tell me about the ventilation of it, didn't tell me about the condition of the timbers both before and afterwards, all of these useful things. And on top of that, it was for the wrong product. It was literally a different spray foam to the one that they'd given me all the information for. So, you know, we're in this kind of bit of a muddle where, you know what, we've got a warranty that's no longer valid on a new build within its 10-year period. We've got spray foam in the loft, which is the wrong product for what they think is there. Should it be removed to make the warranty even more invalid? Should it be left? It's all a bit of a nightmare. So yeah, it's a complicated situation which we're still bumbling along until we find some kind of realistic issue. On top of that, you get all of the people that were selling spray foam are now basically selling removal or spray foam. So yeah, I have my massive concerns about the whole thing. Just kind of pick up on these last ones. Someone's just commented, I'll kind of flick through some of these. Scandinavia is almost free electricity, so from vast hydro power stations. Yes, it's a different situation, and we kind of need to allow for that, so it's not always the same. Why are cavity walls in modern low-rise properties so wide? Sometimes half the cavity has no insulation. Well, I would argue that air within a cavity is not no insulation. Air itself acts as insulation. It has an insulative effect. So even an unfilled cavity is still technically insulated because exactly the same way the air trapped in your woolly jumper is insulation. Of course, if you've got a woolly jumper in the wind, you lose all that air, you lose all the insulation, and therefore you get cold. But you know, on a still day, that jumper is providing you with warmth because of the trapped air. So in exactly the same way in our cavity, if we can trap more air, we're providing a better level of insulation. We're also protecting it from penetrating damp because we do have the ability for the water to run down and pour out of our weep holes. I've seen a lot of people still using them a lot. What are your thoughts on them? Again, I don't want to get into particular types of systems as we're kind of running into the end of our time. Thank you. I've actually managed to finish on time, which is a rarity for me. But there you go. I'm getting older and wiser.
I'd like to thank Tim for presenting and to everyone who has joined us this morning. As a reminder, this session has been recorded and will be uploaded to both the CABE website and our YouTube channel soon, which you can share with colleagues. With that, I'll wrap things up for today. Thanks again to Tim and for everyone for taking part today, and we will hopefully see you at the next CABE webinar. Goodbye.